Hello everyone, welcome to TV Math. In our today's session, we want to look at question number 14 for Wakisha Joint Mock. And it says use Maclaurin theorem to expand 1 divided by the square root of 1 plus x up to the term in x to the power 3. So we need to refer to the Maclaurin theorem, which says that if you have f of x, that f of x is approximately equal to f of 0 plus f derivative of 0 of x, and then plus f double derivative of 0 of x squared divided by 2 factorial, then plus f a triple derivative of 0 x to power 3 divided by 3 factorial, and so on. So this is by Maclaurin's theorem. So what we shall do is we shall relate our f of x to be same as 1 divided by the square root of 1 plus x. So we need to express this f of x in form of this expression. So according to what we need f of 0, and we know f of x, so we can easily get f of 0, and f of 0 is same as 1 upon the square root of 1 plus 0, and this is 1 upon 1. So this will give us 1. So f of 0 is same as 1. Next, we need f derivative of 0, then times x. So to get f derivative of 0, we need to first of all differentiate f of x. So our f of x is same as 1 plus x to the power of negative a half. That is when we bring this one in the numerator. And it means now when you differentiate this, you will drop the power, that is negative a half, then reduce the power by 1. And that will be negative 3 by 2. So the derivative of what we have in the bracket is actually 1. So times 1, which remains the same expression. So this can be written as negative 1 upon 2, then 1 plus x to the power of 3 by 2. So this is f derivative of x. And of course, we can get f derivative of 0, which is negative 1 upon 2 into 1 plus 0. So it remains 1. So this will give us negative 1 upon 2 as a derivative of 0. Now, having got f derivative of 0 as negative a half, it means we have so far achieved this, and we have already achieved this. So next, we look at f double derivative of 0. But to get f double derivative of 0, you need to first of all differentiate f derivative of x. So we already have our f derivative of x here. So referring to that, looking at f derivative of x as negative a half into 1 plus x to power negative 3 over 2. We shall now get f double derivative of x, and this will be same as negative a half times negative 3 over 2 into 1 plus x to the power of negative 5 divided by 2. So when you get this and you subtract 1, you will be able to get this. So this will be giving us 3 out of 4 into 1 plus x to the power of negative 5 divided by 2, and this will be f double derivative of x. So having got f double derivative of x, we can now get f double derivative of 0, since we can easily write this as 3 out of 4 into 1 plus x to the power of 5 by 2. So f double derivative of 0 will be same as 3 upon 4 into 1 plus 0 to the power of 5 divided by 2. So this will remain 3 divided by 4 as f double derivative of 0. So we have got f double derivative of 0. So next, we shall talk about f triple derivative of x. So to look at f triple derivative of x, we shall differentiate f double derivative of x. So let us differentiate this. To differentiate this, we shall have 3 divided by 4 times negative 5 divided by 2 into 1 plus x to the power. We shall subtract 1 here, and that will give us negative 7 divided by 2. So this can be simplified as negative 15 over 8 into 1 plus x to the power of negative 7 by 2. But this can be written as negative 15 over 8 into 1 plus x to the power of 7 divided by 2. So this is f triple derivative of x, and we can go on and get f triple derivative of 0, which is negative 15 divided by 8 into 1 plus 0 to to the power of 7 by 2, and this will remain negative 15 divided by 8. So this is f triple derivative of 0. So looking at what we need to expand up to x to power 3. So we need to expand up to this given point. So now we shall have to substitute for f of 0, f derivative of 0, for this one here and for this, and that will be our expression. So substituting for that from this given equation here, which I can call equation star. So from equation star, we shall have, from equation star, we shall have f of x. Our f of x is 1 upon the square root of 1 plus x. So it will be approximately equal to, f of 0, we have it as 1. Then f derivative of 0, we have it as negative half. So we shall substitute this one and for this one. So that will give us, this will give us 1 minus a half of x. And then we shall substitute for f double derivative, which is 3 by 4. So 3 divided by 4 of x divided by 2 factorial. And then plus, the next one is actually negative 15 divided by 8 of, this is x squared, of x to power 3. And this is divided by 3 factorial. 3 factorial is 6. So that is 6. So finally, this will be able to give us 1 minus a half of x. This 2 factorial is 2. So we shall have a 3 over 8 of x squared, and then minus 15 over, so when you get 8 times 6 will give us 48 of x to the power 3. So that is what we are having there. So in general, we shall have our expression 15 over 48 can be reduced. So in general, we shall have this expression equaling to 1 minus a half of x plus 3 out of 8 of x squared, and then minus by 3, it is 5. So we shall have 5 over 16 of x to the power 3. So this would be our expansion of f of x, which f of x is 1 upon the square root of 1 plus x. And you have expanded this up to x to the power 3. So that would be your answer. Let us look at part B, which says that given e to the power x, which is equal to tan 2y, we prove that the 2y dx squared is same as this expression. So what we shall do, looking at the solution, we are given that tan 2y is actually equal to e to the power x. So what we can do here is to differentiate on both sides with respect to x. So we shall differentiate with respect to x tan of 2y. We shall also differentiate with respect to x e of x. So when you differentiate this, you'll be able to get, when you differentiate tan 2y, this 2 will come out and it will be 2. Differentiate tan, it becomes x squared, then 2y. We are differentiating y with respect to x, so it will be dy dx. And this will be equal to, when you differentiate e to power x, it remains e to the power of x. Meaning from here, we shall have dy dx, which is equal to e to power x divided by 2 sec squared of 2y. So that is exactly what we are having. Now, having looked at this, we shall now have this expression simplified as e to power x divided by 2 sec squared is same as 1 plus tan squared of 2y. So this can as well be written as e to power x divided by 2 into 1 plus tan squared of 2y. We already have that tan of 2y is equal to e to power x. So it means, it implies that tan squared of 2y is same as e to power x also squared. And this is same as e to the power of 2x. So we shall have this as 1 plus e to the power of 2x, and this will be your dy dx. So dy dx is this. Now we need to go on and obtain the 2y dx squared, which is same as differentiating this expression for the second time. Now let us look at how best we can get the 2y dx squared. So what we shall do is differentiate this expression. So we shall call this one u, and this will be v. So we shall use what we call the quotient rule. So you record the quotient rule. So that is what we shall use. So let us look at how best we can do that. So we are having dy dx as e to power x over 2 into 1 plus e to the power of 2x. This is what we are having so far, and we need to differentiate this for the second time. Now, from the quotient rule, which says that dy dx is actually same as v du dx minus u dv dx over v squared. So this is what we shall be using. Now, this will imply that we shall let our u to be e to power x, meaning that when you differentiate u with respect to x, you get e to power x, and our v will be 2 into 1 plus e to power 2x, and of course this is same as having 2 plus 2 e to the power of 2x. And when you differentiate this with respect to x, you'll be able to get this as 4 e to the power of 2x. Now, this will imply that when we differentiate this expression with respect to x, when we differentiate this expression with respect to x, we shall be able to get our d2y dx squared, which will be equal to, now we are applying this rule here. So v is 2 into 1 plus e to power 2x, then times that is v du dx, that is e to power x, then minus u is e to power x, then dv dx is 4 e to power 2x. We are dividing the whole of this by 2 into 1 plus e to power 2x, but the whole of this is actually squared. So this will be, let us try to simplify this. And 2e to power x times 1 will remain 2e to power x. 2 times e to power 2x times e to power 2x will give us 2e to the power of 3x. Because you are getting e to power 2x, you are multiplying it with e to power x. So it is same as maintaining e and adding their x is 2x, and this will be e to power 3x. Then we are subtracting 4 e to power 3x. The whole of this is divided by 4 into 1 plus e to power 2x. Then the whole of this is also squared. So the 2y dx squared will give us, let us try to simplify this expression. So we shall have 2 e to power x minus 2 e to power 3x, and this is divided by 4 into 1 plus e to power 2x, and the whole of this is squared. So finally, this will be able to give us 2 is common, so you can put it out, and you remain with e to power x minus e to power 3x, and this is 4 into 1 plus e to power 2x, and this is squared. So from here, these two will reduce this to give us e to power x minus e to power 3x, and this is divided by 1 plus e to power 2x, and the whole of this is squared.
Yeah.